Hello everyone and welcome to this lecture. In this lecture, we are going to cover the intuition of multiple linear regression. So let's get started. All right. So if you guys remember from the previous project, is that we covered simple linear regression. And the goal of a simple linear regression is to obtain a relationship, or what we call it a mathematical model, that can govern the relationship between two variables only. And that's a very important, I would say, keyword, that we're only dealing with two variables only when we deal with simple linear regression. And actually that's why we call it simple to start with. So what we do is that on the x-axis, we can plot, for example, the age, okay, which is the number of years, versus our insurance cost. So that's the output. Okay, and that's it. We call it a day, we're good to go, and we only have one variable only as an input, which is my number of years. And what we could do is that we can plot all these data points, okay, and what we could do afterwards is that we can try to fit the best line that can go through all that data. And the objective is to try to obtain the coefficients, which is m and b, where if you guys recall, m was the slope of the line, and b is the y-intercept, which is how much did we intercept here in the y-axis. And if you guys remember, if b was set to 0, that means this line will be forced to go or to pass through the origin. All right, okay. So that's from a very high level, and again, here we have our independent variable, which is x, which is age in this case. Here I have my dependent variable, which is my insurance premium, which is my y value. And the objective is to try to obtain the optimized parameters for m and b, and that's my model. And I'm going to show you guys as well in this case study how to obtain the m and b mathematically, and how to apply a gradient descent algorithm to try to obtain these parameters. I'm going to show you guys coming up in the next couple of lectures. But that's all what we have for the simple linear regression. Okay. The problem in our case study is that we are actually dealing with multiple features. If you guys remember, if we go back, here we have, these are the number of features that we're dealing with. We're dealing with BMI, with children, with a smoker or not, region, and so on. So now I can't use a simple linear regression model, and simply I have to take it to the next level and apply a multiple linear regression model. So let's take a look at it. Here we go. It's pretty simple. As you guys guessed it, here I have my dependent variable, which is insurance cost, which is the output, would be function of multiple inputs, right? Now I have x1, I have x2, I have x3, and so on, up until xn. And these are my independent variables, such as age, smoking habits, region, and so on. And now I have multiple coefficients. Actually, I have b1, which is the coefficient of x1. I have b2, which is the coefficient of x2, and so on. And as well, I have a bias signal, or b node. Basically, this will be equivalent to this one, which is the y-intercept. So basically, I have the fixed, or just a constant, okay? And then I have the multiple coefficients as well, depending on how many variables do I have here in this case, okay? So multiple linear regression examine the relationship between more than two variables. And recall that simple linear regression is a statistical model that examines linear relationship between only two variables. Here we took it to the next level, and each independent variable, which is x1 or x2 and so on, will has its own corresponding coefficient. Okay, so now it actually now I need to obtain a lot more parameters compared to before. Before I only had to obtain m and b. Now I need to obtain much more parameters, and that's why I'm going to show you guys how to obtain these parameters and how to optimize it in the next couple of lectures. Okay? All right. So that's all what I have for this lecture. I hope you guys enjoyed it. In the next lecture, I'm going to cover the regression metrics and KPIs. So we're going to learn how to assess regression models, how to know the difference between mean square error, mean absolute error, between R-square, adjusted R-square, and it's going to be tons of fun. Please stay tuned and please enjoy AWS SageMaker practical course, and I will see you guys in the next lecture.